Okay, so hi, I'm Rolf from Keysight Technologies. I'm a software developer, and I'm here to introduce to you OpenTAP, which is an open source test automation project we have been working on. It was just released as open source last May, so we are really excited to get to kind of present this system to you. It's based on a test and measurement sequencer and the libraries associated with it. So I'll just quickly explain what is OpenTAP and then go through a short demo afterwards. So as I said, I work at Keysight Technologies, and this OpenTAP is one of the first software projects that are open source that we're doing. So Keysight Technologies is an electronics test and measurement company. And some of our products are these instruments you see out here to the right. It's measurement equipment, and of course that includes some software component as well. So you really need to control these instruments, and that's where you need a test sequencer basically to set up your tests. And so our ambition is really to have to create the best test and measurement solutions. So to have that, we believe you need the best hardware and you need the best software. And we strongly believe that parts of having the best software is embracing the open source concept wherever when it kind of makes sense, right? And we believe that OpenTAP is a project where it really makes good sense to do open source. So we have identified something we call the automation challenge, and it's something we noticed 9 years ago when we actually started this test sequencer project. And the thing is that the ecosystem of test sequencers is split between homegrown solutions and proprietary solutions. And so the homegrown solutions have the problem that they're often very costly or very error prone, right? You can have maybe very cheap software if it includes a lot of bugs. Or a very expensive software, it is absolutely not acceptable to have any bugs. And then you have the proprietary software that kind of forces you into this vendor login situation where you're not maybe able to extend it with new hardware, new devices. And you also have the problem that if the vendor stops maintaining it, you're pretty much lost if you need some bugs repaired. So what we saw was, and this also actually applied to our own company, is that often, companies start making new test solutions, that are all very similar. It has like the same kind of GUIs, the same kind of device drivers, the same kind of logging and result capabilities. And that's really not what we thought was a very good situation. And so what we want is to help people kind of leverage the work of others and kind of to help those people who have one specific device they're working with, that they can just kind of focus on that, be the experts on that device. So our goal is to make test and measurement automation effortless. And we have some ideals that it kind of applies to all software, I think. But for OpenTAP especially, it's simplicity. If you don't really need it, it shouldn't be in your way. And that comes into that we have a modular architecture that kind of handles this. And the same goes for the scalability. It should be lightweight and integrate well with other things. You should be able to fire it up in a Docker container, run it on an Android phone or a desktop computer or what have you. And then lastly, speed is very important for tests. And I mean, if you're doing manufacturing, you need to make sure that the test goes as fast as possible. And of course, also a very important thing is the speed of development. How many man hours do you need? So what is OpenTAP? OpenTAP is really based around a test sequencer. So it's a software, right? It has a kind of modular, a very modular actually, plug-in architecture that allows you to kind of extend many aspects of it with custom code. It's developer friendly, and that's very important, right? Because we want people to develop plugins for this. So we really develop this with a developer first mindset. It's a growing community, and these these over here you see are some of the people who are involved, and people who are interested in doing tests in the best way, right? And so it's based on .NET Standard, which is the open source .NET runtime from Microsoft, and it supports we support Windows and Linux, and it's open source under the MPL v2 license, and it has we use the open core kind of strategy there. So the OpenTAP is open source, and we have some proprietary software as well that you can get, but we also have a lot of like open source plugins for it that you can use. And in this demo and in this talk today, I will only be talking about the open source stuff, more or less. So yeah, so I'm really excited about this software because I've been developing test solutions myself, and I really enjoy having to work with some software that is developed with the developer-friendly mindset. Yeah, and actually also it kind of, we started coming to FOSDEM a couple of years ago, and FOSDEM was also one of the things that kind of inspired us to start, looking at an open source solution to this. So what's a test sequencer? A test sequencer is a piece of software that can be used to create, modify, and run a sequence of test steps. So some important concepts here are a test plan, which is a sequence of test steps, right? The test steps themselves, which encapsulate some piece of functionality. It could be a measurement or some hardware control. It's also important, have to read some resources. You have your devices under tests, dots. You have your measurement instruments. Then you have your result listeners for processing and storing results. Yeah, so, and up here in the corner, we'll kind of talk more about that. But that's to show you kind of it's kind of a modular architecture, right? And here, it's just a picture of, that, the test steps themselves, they're up in the corner, and those are like plugins you put into the system to build your solution. Okay, so test steps and test plans. So test steps are like the atoms of OpenTAP. It's really how you kind of build your test sequence. So as I said, test steps encapsulate some functionality. They have some settings, like which frequency are you measuring or something like that. And they sometimes use resources. If it's a measurement, they use resources, or if they control some piece of hardware. And they can also have child steps. So it's kind of a recursive system, right? Steps can have child steps, can have child steps. And so they're all inside this test plan, which is a sequence of test steps. And the test plan kind of manages the control when to connect to instruments and disconnect and stuff like that. And on the right side here, you see just an example of some test steps. You have some hierarchies and stuff going on. So we talk a bit about test execution flow, just to explain a bit how these things work. So here you have like this kind of very simple test plan of 3 test steps that we just want to run after each other. And so first, the test plan will kind of figure out which are the required resources for this test plan, and then it will open those or connect to them. It depends a bit on what kind of instrument. Like, is it is it an SQL database you want to publish results to, or is it like a USB device or something like that? It takes some time to open your resources. That's why this kind of happens in parallel. Then you come to your test execution phase, where you run all the steps here in sequence, and finally you close all the resources that you're using. And so all these flow things we have here, they can actually be modified so just to be clear, so this here over here marks kind of the end of the test plan run, right? And so, but all these flow things can actually be modified by plugins. You can make a plugin that makes, the resources associated to a specific step, that it only opens before the step runs and after the step closes. Like if you have a very long running test plan, maybe you don't want to take up the resources for the whole length of the test plan. So you want to more finely control it, and that can be done using plugins. Yeah, then we have some results. Results are very important. this could just be, so results comes from test steps. And this could just be a verdict, like pass or fail. Or it could be the results of some measurements. Here I'm showing just the measurements that I'm making in the demo later. Or it could be a simple log message. So yeah, we have like this message passing system with some specific rules for how results flow through the system, and to kind of make sure that results are processed in the most optimal way and not kind of blocking the test plan execution time, but kind of is shipped away on different threads to process that as efficiently as possible. Okay, so this slide here is kind of the core idea of OpenTAP, you can say. You can see all these, so OpenTAP is actually being developed in Denmark. That's why we use all these Lego bricks. But it's kind of the metaphor, right? So if you look at you have the tested plugins, you have your resource plugins, you have your user interfaces, and your result listener plugins. Those are all different kind of parts of the system, right? And you can see the different colors bricks are kind of the different plugins you can have. And the color this has not really any significance. So an important thing here is like how does the different parts communicate? So you can see the user interface, there's an arrow going to the OpenTAP brick, right? And that's because that kind of communication is isolated. And that's also for the result listener plugins. That's also kind of isolated, that communication. So there's no direct communication between the test steps and the result listeners, for example. So results are kind of, so that's kind of encapsulated. But then if you look at the test step plugins and the resource plugins, you can see this arrow here. And that's because like test steps talk directly to instruments, for example. And then we have some plugins that kind of fall out of the category. Like a Python plugin, we have like that. The Python plugin kind of allows you to implement all the other kinds of plugins, but instead of in C#, you can now implement them in Python. Okay, so you take these bricks and you kind of put them together, and then you kind of create your solution. So your plugin, you probably have some code that you need because maybe you know how to control your device or your instrument, or maybe you just have some special things you need. It could also be just a special kinds of results you want to, or a special database you want to store your results in or something like that. So that this is kind of the idea, right? You put together your solution. And you can find a lot of bricks for your solution at the packages.opentap.io. This is our main package repository. And so if you go and develop your own plugins, you can also get it into this repository and share it with people. So yeah, it's just like, a package manager just for TAP. Okay, so then I'll go through a couple of cases of things that have been developed with OpenTAP. So here's something called the Triangle project, which is an EU project that uses OpenTAP to do a benchmark on phones. So you kind of connect your phone and you can run some tests that tries to figure out the performance characteristics of this phone and give it like a rating. So is this a very good phone or is it a bad phone? So things that you can measure like battery drain and UI frame rate and stuff like that. And so the thing that TAP does is control this sequence of test steps that tells the dot to maybe start or maybe it tells an instrument to start measuring the current drain of the phone or something like that. And then in the meantime, go to YouTube and watch a video and see how that affects the battery drain and things like that. Is what this kind of project has been doing. And I think, so it's kind of, a very complex scenario where you have, like a very complex system that you're trying to measure some of these parameters on. And down here you can see, this just to show this is kind of this is like a solution, right, with your bricks. So then we have another thing is web API tester, and that's something that's under development. And it's a plugin for testing HTTP APIs, like REST. So you can make a test plan that then sends some REST requests to a server. And that's just test steps for OpenTAP. It's just test step plugins. You put in, write your URL and your endpoint, and then you can get the data back and to try to figure out, you make a script that basically says if the this was the expected result. And the GUI you see here is our open source text-based UI. And it's, I think it's quite, I mean, it looks old school, but it's quite convenient because it's really fast. And it's also like you can, if you have like a Docker running, like you can like SSH into it and open this GUI and look at your test plans. Yeah, so this is a pretty simple solution with only like 4 basic components here. And then finally, we have the subject of our demo, which is a little like a hardware device called Pocket Science Lab, which is developed by, it's open source hardware that's developed by FOSDEM, and it has some simple oscilloscopes and a waveform generator things on it. We thought it would be fun. We saw it last year here in FOSDEM and talked to the people there, and we thought it would be fun to kind of use it for our demo. And so what we are going to do is, well, I forgot to find the thing actually. Okay, so what we'll do is we'll connect the wave generator to the oscilloscope, channel 1 and channel 2, and then we'll connect it to the PC. And then we'll do some of these. We'll try to do like a frequency sweep and a phase sweep on the wave generator and see what happens. So yeah, I'll just find the device because I forgot to take it out of my backpack. Yeah, so here it is. I'll connect these first. Yeah. Yeah, okay, sorry about that. And there we go. Okay. So I have, if you can see my screen. Yeah, okay, it's pretty small. Okay, so here I have some code, basically. It's a class, that implements a test step in OpenTAP. And I will just compile it. I have this in there. So this project here is like a C# project and a Python project, and it contains the driver for the instrument and some test steps to do some measurements on the instrument. And yeah, so now I compiled it, and the project itself includes the OpenTAP Nugget package, which means that OpenTAP gets deployed into my debug folder here. So you can see if I do I don't know if you can. I think it's okay. Okay, so you can see this is my debug folder, and I have tap.exe here. That's how you basically your entry point to OpenTAP. And then I have the PSL CS test, which is the DLL that contains my plugins. But I need some kind of graphical user interface to create a test plan, so I just install the TUI. Okay, and then I also need, so now I've installed the user interface, and I also need a CSV file for saving results, so I'll also install that plugin. And then SQLite and PostgreSQL, like that. Okay, so now we want to create our test plan. I'll open up the user interface. This is like the old school one I'm using. You also have like some like an editor, like you can download like community edition editor if you want. And then I'll create my test plan. So I'll just create a setup sine generator step that sets up the like sine waves on the generator. And you can see over here on the settings, we need an instrument and set up the channel and the frequency. And the channel is fine, so I'll just call this like 1000 hertz. And now I'll go and add the instrument here. So now we have this instrument in our instrument settings. Oh, and then I will also go and add the results, CSV database, SQLite database, and here you can see the settings for those. Okay, and then I just need to go and configure this. Okay, so now this step is configured, but we also need to measure something. So I'll add the measure sample step. Oh. And the measure sample step, it's just like measure some samples with the oscilloscope. Basic stuff. Symbol.tap plan. Okay. I'll quit here. All right. So now I'll just use the CLI to run the test plan. So I just like this. Oh. I don't need right now to do that. Okay. So yeah, so you can see it ran the test plan. This is just a log file. And the results that the CSV file result listener is saving is inside this result folder. So just write this trace like that. I'll fire up Excel. You can use whatever you want. And I'll just like plot this scatter chart. So yeah, that looks like what you'd expect from like a sine wave. 10,000 samples. So let's try to create something a bit more advanced. I'll open up my test plan again here. And let's create a new test step. So we'll use one of the things from OpenTAP itself, which is the sweep loop. This is essentially just a plugin from the basic steps. So sweep loop can sweep across a property that's a setting. So when I add, and so I have this step called measure RMS voltage that I'll put into the sweep loop as a child step. And the measure RMS voltage will measure RMS voltage on the, the oscilloscope and set the frequency on the generator, and it's kind of assume that those two are connected. And so these are the settings for this step. So go to the sweep. That was actually the wrong sweep loop I added. We can do that in another demo. Sweep loop range. It's a bit simpler to explain what goes on there. Okay, so then I'll select, for sweep loop range, I will select sweep frequency as a parameter. And let's start at 100 hertz and finish at 1,000 hertz, because this device in the specs, it says that it goes up to 5,000 hertz. So let's just test that it works at that level. Yeah. Okay. Looks good. Then we'll save it and go to the command line again and then run it. So now we're sweeping across frequencies. You can see the hertz out here. Actually, I should have done an exponential sweep, but I think this gets the point across. Okay, then we can look at the results again. And then insert scatter chart. Okay. So what we have here is the RMS voltage at all the different frequencies. And you can see here around 5,000, it kind of starts trailing off, right? So the output of the generator starts to go down as we exceed the limit of the generator. And so you can say, yeah, maybe you could kind of calibrate that out to boost the signal or something, but we also don't know if there's any distortion going on or something like that. So that would be another test you would make. Okay, so another thing I have, we just maybe delete these two. So I also have something that can measure the difference in the phases, because actually there's two generators and two oscilloscopes. So if we just connect those together, we can try to sweep the phase of the generators, because the generators are kind of locked in phase, but you can kind of decide how much you want to shift the phase. So let's just add this one again, sweep loop range. And now we'll sweep the phase, and we'll sweep from 0 to 360, it's degrees, and I will do just 13 points. So we have a step size of 30. And we're measuring 0 and 360. So we're making that measurement twice. Yeah, and then I'll publish this. Yes. Yeah, let's try to run. Okay, so we can go and look at the results again. Difference RMS, I think. Yeah, and there you can see, so I'm subtracting the two signals from each other. And so you can see when the phase is 0, so that they are exactly on top of each other, there's a 0 voltage difference between them. And then when the phase is 180 here, there is a 100% kind of phase difference between them, and you get this, you get a peak that's around 4.4 volts. Yeah, so those are some of like the basic things you can do. So another thing is like, for example, the REST API plugin. You could just put in the kind of a REST tested there instead to test your like a web server, for example. And then it actually is a lot similar to using like Postman or something like that. You can set up your requests and you can just like run a. But then the nice thing is that we have the like CLI tool, so you can just like run your test plan like. Pff. Okay, so maybe a quick last thing. We have these community edition tools here that you can also use. That's part of a product we have. Okay, tab editor, open. So here you can see like the same test plan that we had before, just in like a different style of GUI. But then we can open the, remember I attached the SQLite database. Anyone can really use that. And so here are the results from the different runs we had. And it's pretty convenient. But then you can go and see the results from our previous test plan. They look like this. This is the one, the phase difference we saw. If you go to say like that's the voltage difference. But then this is also a bit interesting, I think. If you split this on the phase, you can kind of, maybe we'll check a line chart here. This seems to be a bit of an error. But then you can see this here, when the phase is 360, you get like a completely correlation between the voltages on both axes, right? They're completely correlated. And then as the phase moves towards, it gets like elliptical, and then as the phase moves towards like, 180 degrees, it kind of turns into like ellipsis that turns on the, it turns a line that's, what do you call it, 90 degrees compared to it. And this here is at 45 degrees or 230. Yeah, so just a little curiosity. I like this chart. I'm not sure it's actually useful for anything, but I just like looking at it. Okay, so yeah, that's my demo basically, and so yeah, thank you for your attention, and yeah, here's some info. Come and see us if you want. If you're interested, come and see us in Building K. We have a stand up in the close to the back entrance. And yeah, if someone of you is really interested in OpenTAP and test automation, we have this developer camp in September. You can come and talk to us if that's of interest. Okay, thanks.